Hi, in our next lab we're going to be using Jobs Methods Lab. In this lab we are going to be able to calculate the chemical formula by using a graph. In this lab we'll be using two calculations, molarity and mole fraction. Molarity is moles of solute over liters of solution. Molarity can be abbreviated by using a capital M, and the equation is concentration and molar. In lab, we'll be calculating the moles of each substance from the concentration. In our pre-lab, one of the moles that you're going to be calculating is the moles of iodine. We're going to do that by giving you a given concentration and a given volume. For example, calculating the number of moles of iodide ion in 0.10 molar potassium iodine solution with a volume of 5 milliliters. We will be using the molarity equation. Molarity equals moles over liters. To do this, you'll plug in your molarity, which is 0.10 molarity. Then your number of moles is going to be your X, and then you're going to have to divide by your number of liters. However, they gave us milliliters, so thus we have to convert it to liters. To do that, we would divide by 1,000, so we would get 0.0005 liters of solution. So to solve, we would simply just have to multiply, and that would give us moles of iodide. The answer would be 0.0005 moles of iodide ion. Now what I want you to do is pause the video and calculate the Calculating the number of moles of lead would be very similar that we did before. To calculate the moles of lead ion in 0.10 molar lead 2 nitrate with a solution volume of 15 milliliters. Once again, yes, you're using your molarity equation. You plug in your molarity, moles is your X, and you have to convert milliliters to liters. So again, dividing by 1,000 and giving you 0.015 liters. Once you multiply them, yes, your answer should be 0.0015 moles of the lead ion. We calculated the moles of iodide ion and the lead ion in the pre-lab test tubes that are set up for you. You're then going to have to calculate the mole fraction. Mole fraction is represented by an X, and it's moles of the substance that you're looking for example, substance A, and then you're dividing by the mole total. Mole total would be the total moles in that particular solution. Here we have the iodine ion and the lead ion. So with the above, we've calculated the moles of iodine ion and the moles of the lead ion. To calculate the mole fraction of the iodine ion, you would have to take the moles of the iodide ion, divide by mole total, which in this case would be moles of the iodine ion plus the moles of the lead ion. So in this particular case, we're going to take 0.0005 moles of the iodide ion, divide by mole total, which is 0.0005 of the iodine ion, plus 0.0015 mole of the lead ion. Once you've done this, your calculation for the mole fraction of the iodine ion should be 0.25. Of course, there are no units because moles over moles would cross out. Now pause the video, and I want you to calculate the mole fraction of the lead ion. Now the calculation for the mole fraction of the lead ion, we could do the same setup, and that means putting the moles of the lead ion over mole total. Or because we only have two ions, all we have to do, since they both have to add up to 1, is take 1 minus the mole fraction of the iodine ion, and we get 0.75. Now for the pre-lab, what I want you to do is calculate the mole fraction of the iodine ion for each of the test tubes that are in the pre-lab. You will have to calculate the moles of the iodide ion, the moles of the lead ion for each test tube because each test tube has a different amount of volume. Once you know the moles, then you can calculate the mole fraction. Now, You show your calculations for about the first 3 test tubes. After that, you're going to see a pattern and it gets repetitive, and it will be easy to complete the rest of the test tubes. Have a great night. Bye.